On September 5, 1977, NASA set out on a daring mission, sending off Explorer 1 into the vast universe with a plan that endured only 5 years. Yet, guess what? Over 40 years later, it's still out there, venturing through new frontiers of space. Anyway, in the spring of 2022, this incredible shuttle sent some strange information back to NASA, leaving even the agency's top researchers confounded. Recently, the shuttle has sent back even more peculiar signals that defy all explanations. As of today, we'll unveil exceptional insights into the data that have remained untold until now. Don't miss it. Explorer 1, a rocket launched long ago, stands as a testament to the incredible curiosity that captivated the globe during the extraordinary decades of the 1960s and 70s. It was a period when the public's imagination was enamored by dreams of wandering beyond our natural limits and exploring the mysteries of distant planets. These dreams were not simply fantasies, they were major impetuses behind one of the most ambitious endeavors in mankind's history, space exploration. During this pivotal period, the U.S. recognized the central importance of understanding and exploring our planetary system. For this cause, discussions of pioneering tasks to send probes to neighboring planets flourished in the late 1960s. In 1972, NASA's brilliant scientists revealed a groundbreaking concept, a 3-axis stabilized spacecraft equipped with a guidance control system rooted in cosmic coordinates. This innovative wonder, similar to a gyroscope, held the promise of enabling the spacecraft to maintain its course as it ventured into the cosmic unknown. Its primary mission was to unveil the secrets of our solar system, a mission that would take it on a journey of significant importance. Explorer 1's objective was set: it was bound for a rendezvous with celestial giants like Jupiter and Saturn. Its goal was to uncover the mysteries of these distant realms and communicate valuable images and data back to Earth, revealing insights into the complex and inspiring phenomena that lay hidden in the depths of space. However, recently, Explorer 1 has embarked on a startling and perplexing chapter in its story. The signals it's begun sending back to Earth have left even the brightest minds at NASA bewildered, sparking interest and concern among scientists and space enthusiasts alike. To better understand this, we must first embark on a journey through some of the significant discoveries made by Explorer 1 while fulfilling its mission. Explorer 1 and its twin, Explorer 2, were launched from Cape Canaveral just a few weeks apart in 1977. Contrary to their numerical order, Explorer 2 launched first on August 20, 1977, while Explorer 1 followed a few weeks later on September 5. However, due to a faster trajectory, Explorer 1 exited the asteroid belt sooner than its twin, having surpassed Explorer 2 by December 15, 1977. Explorer 1 began its Jovian imaging mission in April 1978 when it was about 165 million miles from the planet. After several months of travel, the spacecraft sent back the first space photographs of Earth and the Moon, which had never been seen from such distances before. Starting January 30, 1979, Explorer 1 snapped a photo every 96 seconds for a duration of 100 hours to produce a time-lapse film depicting 10 rotations of Jupiter. The images sent back revealed that Jupiter's atmosphere was more turbulent than during the Pioneer flyby conducted in earlier years. On February 10, 1979, the spacecraft crossed into the Jovian moon system, and by early spring, it discovered a thin ring orbiting Jupiter, less than 19 miles, 30 kilometers, thick. On April 5, 1979, Explorer 1 had its closest encounter with Jupiter, coming within about 174,000 miles. During this excursion, it also made close contact with several of Jupiter's moons at various distances: Amalthea at 261,000 miles, Io at 13,500 miles, Europa at 4,830 miles, Ganymede at 71,280 miles, and Callisto at 78,540 miles. Perhaps the most shocking of Explorer 1's discoveries was that Io has active volcanoes fueled by heat generated by the stretching and contracting the Moon undergoes due to its elliptical orbit around Jupiter. This finding revolutionized scientists' understanding of the moons of the outer planets. The spacecraft also found a thin ring around Jupiter, making it the second planet known to have rings, along with 2 new moons, Phoebe and Métis. Following the Jupiter encounter, Explorer 1 performed a trajectory correction on April 9, 1979, in anticipation of its rendezvous with Saturn. The mission to Saturn marked a critical milestone in its exploration of the outer solar system. It surpassed its predecessor, Pioneer 11, by conducting an extensive investigation of Saturn, which included a thorough analysis of its rings, moons, and magnetic field. As the second spacecraft to encounter Saturn, Explorer 1 aimed to achieve a deeper understanding of this gas giant and its complex planetary system. During its mission at Saturn, Explorer 1 successfully met the majority of its scientific objectives, although there were some challenges, notably with the photopolarimeter experiments, which unfortunately did not function as expected. Nevertheless, the spacecraft made several significant discoveries during its encounter with Saturn, further advancing our knowledge of the planet and its celestial environment. One of Explorer 1's remarkable discoveries was the identification of 3 previously unknown moons, Prometheus and Pandora, often referred to as the shepherding moons due to their role in maintaining the integrity of Saturn's F ring, and Atlas, which also played a shepherding role for its own ring. These discoveries expanded our understanding of Saturn's intricate moon system and the dynamics at play within its rings. Perhaps one of the most essential findings was the study of Saturn's largest moon, Titan. Explorer 1's instruments revealed that Titan had a thick atmosphere obscuring its surface from visible light cameras and telescopes. The composition of its atmosphere resembled Earth's, primarily made up of nitrogen, but it had a surface pressure approximately 1.6 times greater than that of our planet. This captivating revelation raised intriguing questions about the conditions on Titan's surface and its potential for hosting unique environments. The spacecraft also captured stunning images of several other Saturnian moons, including Mimas, Enceladus, Tethys, Dione, and Rhea. These images revealed fine details of Saturn's complex and captivating ring system, offering new insights into the planet's celestial dynamics. Additionally, Explorer 1 contributed to the discovery of Saturn's G-ring, expanding the list of known rings around the gas giant. Explorer 1's journey continued after its primary mission at Saturn, just as it utilized Jupiter's gravity to propel itself toward Saturn. The spacecraft employed a gravity assist at Saturn to adjust its trajectory and increase its speed, setting it on a course that would ultimately lead it out of the solar system, eventually reaching a staggering distance of about 4 billion miles from Earth. One of the most notable moments in Explorer 1's mission occurred when it turned its cameras toward the inner solar system, capturing a powerful image that forever altered our perspective. Earth appeared as a tiny, pale blue dot suspended in the vastness of space. Earth's irrelevance in the universe conveyed a significant directive for humankind, a sign of our planet's delicacy and weakness in the vastness of the cosmos. As this earth-shattering event unfolded, the cameras on Explorer 1 were purposely shut down, denoting a change for the rocket. It had finished its nearby experiences with planets and celestial bodies, and its direction would no longer lead it close to any objects for further investigation. Regardless, Explorer 1's amazing excursion was far from over, as it continued to send information while wandering further into the unfamiliar domains of interstellar space. In 1998, Explorer 1 accomplished a notable achievement by surpassing the distance traveled by Pioneer 10, becoming the farthest artificial object from Earth and embarking on an unmatched odyssey through the universe. 2004 marked an unprecedented achievement as Explorer 1 carved its name into the records of history. It became the first spacecraft to transcend the limits of the heliosphere and venture into the vast expanse known as interstellar space. This incredible journey was not without its adversities, as Explorer 1 navigated through the termination shock, a region where particles move at speeds slower than sound. Inside this wild domain, the solar wind, a maelstrom of charged particles, underwent a momentous change. The result was a surge in both temperature and pressure, a demonstration of the unique forces at play inside this celestial cauldron. In interstellar space, conditions presented an unfathomably different environment. Here, the density and temperature were notably lower, however, it was not devoid of its own unique pressures. As Explorer 1 experienced these novel circumstances, the heliosphere, a protective bubble of solar influence, underwent a dramatic transformation. It compressed, twisted, and exerted force upon the particles it encountered, marking the spacecraft's transition into the obscure realms of heliopause. The journey across the heliopause and the peak of this pivotal odyssey were not without their share of challenges. Explorer 1 bore the brunt of significant overloads and a shock wave as it pushed past the heliosphere's limits. To add to the complexities, the ground-based receiving stations responsible for capturing Explorer 1's vital data fell silent during this critical stage of the mission, leaving the spacecraft to venture into interstellar space with its signals unnoticed by Earth. 8 years later, in the groundbreaking year of 2012, Explorer 1 charted a course across the heliopause, navigating the boundary where solar material converges with the vast realms of particles from distant stars. This noteworthy feat marked the first occurrence of a human-made object wandering into the core of interstellar space, a demonstration of human resourcefulness and ambition. In the following year, 2013, Explorer 1 recorded an exceptional acoustic phenomenon within the vast void. A solar mass ejection sent forth a wave that resonated through the spacecraft's environment, which now held a density diverging significantly from the heliospheric norm. This density was nearly 3 times greater than earlier estimates, and the distinct high-pitched tone of the signal provided definitive evidence of Explorer 1's foray into this grandiose domain. As Explorer 1 embarked on ensuing years of its interstellar journey, it encountered a series of solar waves, each a source of significant data sent back to Earth. These events not only facilitated the development of advanced models of the solar wind but also afforded researchers the opportunity to examine the complex interaction between the heliosphere and the interstellar medium. In 2017, the mission team orchestrated a daring achievement, reigniting Explorer 1's backup thrusters after a hiatus of 37 years. This astounding demonstration of engineering resilience ensured the spacecraft's continued venture into the cosmic unknown, unencumbered by the passage of time. Fast forward to 2021, and Explorer 1 found itself amid what NASA aptly named clean interstellar waters. Here, it embarked on a unique undertaking, conducting continuous measurements of material density within the interstellar realm. The mission team recognized changes in the environment by closely monitoring the frequency of signals emanating from the probe. Higher electron densities correlated with elevated sound frequencies, while lower densities produced a mellower tone. Curiously, the team reported sporadic dips in signal tone, sometimes resembling readings similar to Earth's atmospheric conditions. However, as the schedule progressed into mid-2022, the celebrated veteran of space exploration encountered a perplexing mystery. It began communicating distorted telemetry data. This bewildering problem confounded the team of specialists entrusted with its care. The Explorer 1 probe and its intricate systems appeared to be functioning normally, dutifully following commands received from Earth, performing its tasks obediently, and collecting significant scientific data to send back to its home planet. Yet beneath the facade of normalcy lay a perplexing anomaly that undermined the integrity of this iconic space Voyager. The Attitude Control and Articulation System, ACS, responsible for maintaining Explorer 1's orientation toward Earth and ensuring consistent communication, began to display erratic behavior. Conducting the mission gave signals that were a long way from dependable, delivering the rocket's position information apparently randomized. This dilemma was no insignificant matter. A disappointment of the AAC might actually spell the deficiency of the rocket itself. The AAC proceeded to convey a reasonably solid signal, yet it was mired in the mystery of sporadic positioning information that opposed regular explanation. As this baffling circumstance unfurled, the seasoned group of engineers and scientists at NASA found themselves in a complicated problem. Adding to the complexity of the situation was the fact that Explorer 1 didn't start in experimental mode, a situation in which a spacecraft typically defaults to performing only its most fundamental capabilities while conceding access to diagnostic hardware and software. Thus, the engineers had to endure a nerve-wracking wait of more than 20 hours before they could begin the data exchange necessary to resolve the issue. Exploring this astronomical puzzle was further complicated by the shuttle's aging parts. While NASA's press administration shunned specifying the duration of Explorer 1's perplexing location issue, they reassured the world that their dedicated team of engineers was ready to adapt to these challenging working conditions. Suzanne Dodd, the task manager for both Explorer 1 and Explorer 2 at NASA's Jet Propulsion Laboratory in Southern California, emphasized that such mysteries were not totally unforeseen at this phase of the mission. After all, both rockets had surpassed their expected life expectancies, having thrived in an environment overflowing with radiation challenges as they traveled through interstellar space. In a remarkable turn, the lost spacecraft was eventually recovered and restored to its trajectory in August 2022. The culprit behind the confounding telemetry information was identified. An onboard computer that had malfunctioned many years earlier had suddenly sprung back to life, attaching itself to the data transmission chain. This long-dormant computer, previously overlooked by the team, emerged as the source of the unpredictable readings. When suspicions arose that this inactive computer was at the core of the issue, a decision was made, with minimal risk considerations, to train the AAC's team to divert data to the functioning computer. This action successfully restored the transmission of telemetry, and Explorer 1 resumed its place in NASA's spacecraft development program. Despite having resolved the mystery, NASA engineers remained perplexed by one lingering question: why had the AAC started transmitting data through the non-working computer? The prevailing hypothesis was that the AAC had possibly received an erroneous command from another onboard computer, suggesting the presence of a malfunction elsewhere on the shuttle while the team continued their quest for this elusive root cause. The fact that the situation posed no long-term threat to the integrity of Explorer 1 gave them some assurance. Suzanne Dodd expressed optimism, stating, "We will do a full AAC memory read and check everything top to bottom. This will help us diagnose the issue that caused the telemetry mistakes and lead to further investigations." As of today, Explorer 1 continues its inspiring journey, sending back new insights about the mysteries of interstellar space. NASA estimates that the rocket's motors will remain functional at least until 2025, with an annual decay of around 4 watts in electrical power production, limiting the number of systems the generator can support. To alleviate this challenge, mission engineers have prudently deactivated radiators, focusing on the noble mission of space exploration. Notably, no scientific instruments have been sacrificed due to reduced power, and the spacecraft undauntedly gathers data with its sophisticated beam instrument, plasma instrument, magnetometer, and low-energy charged particle instrument. The Explorer team vigorously attempts to extend the collection of extraordinary scientific data, ensuring that Explorer 1 continues to traverse the vast expanse, covering many more miles before it ultimately enters its celestial sleep.